All right, let's see this particular question. Count occurrences of anagrams, right? So we are given a word pat, this one, and a text txt, right? So essentially we are given two strings. One is named as txt, another one is named as pat. What we need to do is we need to return the count of occurrences of anagrams of the word pat in text, right? So what we need to do is essentially we need to just find all the anagrams wherever the any anagram of this particular pat appears in this particular text, and we need to find return back the total count of such occurrences, right? And what is an anagram? Anagram is basically for a given particular string. An anagram of it would have all the letters, all the alphabets present in that particular original string, but then they can be in any order, right? And there cannot be any extra letter as well, any extra alphabet as well. For example, if I go on to find the anagrams of Pat, it should only contain these four letters, right? F, F, O, R, right? F should appear twice, O and R should appear once, and there should be no other letter, and these four should only be the letters in that particular string, if I'm calling it as the anagram, and they can appear in any order. For example, ROFF is a valid anagram, OFRF is a valid anagram. So any valid rearrangement, any order arrangement of these four letters would be a valid anagram of this particular string, right? Now what I need to do is I need to find the all the occurrences, the count of all the occurrences of any anagram of this particular string in this particular string, right, in text, right? So let's do one thing. I just added an extra F over here just to explain that we also have to take care of the duplicates. But for now, let me do one thing. Let me remove F, one F for simplicity, right? Now, if you see, uh, in this particular text, FOR will be an anagram of FOR because they are the same string, so they will be anagrams as well. So FOR is an anagram of FOR. So I found one occurrence over here. Then if you see ORF is another anagram of FOR. So, again, this will be one occurrence. And then OFR is another anagram of FOR, right? So that will be another occurrence, right? So in this way, I will have my total count as 3, and that's what my output will be, right? I will return the count of the total occurrences of anagrams of this particular string in this particular string text, right? So that's the problem statement. Now maybe you can try to write a solution for this. Pause this video, think of a solution, and once you are done, you can come back and check my solution, right? So now what we can do is essentially to start with, we can declare two index arrays, right? So when I say index arrays, what I mean is these arrays will be of constant size, right? And the size of these index arrays will be actually equal to the number of English language alphabets, right? And I'll just tell you why we are doing this in a minute. But essentially, we are not like declaring, uh, you know, an array of size which depends on the size of the input. We are just declaring two arrays of constant size. No matter what is the size of the input, how long it is, how big it is, the size of the index arrays will always be equal to the number of uh, English language alphabets, right? Now, let me just write it over here, what I'm saying. So I will have two index arrays. One I will maintain for text, and one I will maintain for pat, right? Now what I will do is initially I will just initialize all the indexes of both these index arrays to 0, right? Similarly for this, right? Right. Now what I will do is I will just iterate over this pat string initially, right? And I will update the corresponding indexes of each of these alphabets that I see in this particular pat string to actually a value which is equal to the number of occurrences of that particular alphabet in this pat string, right? So for example, F appears once, right? So the corresponding index of F in this index pat string I will just update to 1, right? Similarly I will do for O, similarly I'll do for R. Now if there were two F's over here like this, right, I would have updated the corresponding index of F to 2, right? Similarly I would have done whatever was the number of occurrences for each of the alphabet over here, right? I would just update the corresponding string, corresponding index in this particular array for this particular alphabet to the number of occurrences that it actually appears over here in this particular string pat, right? That's what I will do initially. Now what I will do over here is in the text string, I will maintain a sliding window, right? So when I say a sliding window, uh, I will have two pointers over here, right? And this sliding window will be of fixed size, right? And the size will be equal to the number of alphabets that I have in the pat, right? So the size of the window will essentially be equal to the size of the pat string, right? And then what I will do is I will keep sliding that window by removing one element from the beginning and adding one new next element at the end, right? That's what I will keep doing. And what I will do is for any given window at any point in time, whatever the window is, I will update the index text, the corresponding indexes of all the alphabets in the current window of text, right? So for example, to start with, if this is my window from, let me just use this. If like to start with, if this is my window F to R, right? So I will have index text updated with the corresponding indexes, like in the corresponding indexes of each of the alphabets of the current window, I will have values equal to the number of occurrences of those each alphabet in this current window. Same thing what we did over here for PAT, we will do over here, but we will do it only for the current window of fixed size being equal to the size of the PAT, right? So that's what we will do. And then what we will do is we will keep sliding this particular window. And as we are sliding, we will keep decrementing whatever we are removing, right? And whatever we are adding, whichever alphabet, the corresponding index, we will keep incrementing, right? At every step as we are moving, right? And then at every step, what we will do is we will keep comparing these two index arrays, right? For index text and index pat. And whenever they are equal, we can say that we have encountered an anagram, right? Which is quite intuitive because all the letters which are present over here in index pat, we have encountered the same alphabets in index text also with the same number of occurrences, right? That's why they are equal, right? And so we can say if they are equal at any point in time, we have encountered an anagram, and we can just increment the count that we are maintaining to track the number of anagrams that we have encountered by one, right? So that's what we will keep doing. And in the end, once we have like traversed the entire text array till the end, we will just return the count. That will be our output, right? So I hope you understood the intuition behind this problem. Now space complexity, as we discussed, would be just constant, right? It would be order of 1 because these would be constant size always. And the time complexity would be order of n because we are scanning both these arrays just once, right? Entirely. So that would be order of n. So this is the solution, entire solution of this particular problem. Now maybe let's try to code this. All right, so let's implement this solution now. So what I'll do is I'll create a function search, right? Search, and then it will accept two variables, pattern and text, right? Now what I will do is I will declare and initialize my index arrays. So first one will be index text. It will be all zeros, and the size will be constant, which I will keep as 123. Now why 123? Because over here we are only concerned with the English alphabets, English alphabets, right? And the maximum ASCII value that any English alphabet can hold is 122, right? It cannot be any further than that. That's why I've taken 123, but you can as well take it as 256, which is the total number of ASCII values present in case the question says that you also can have special characters and things like that, right? So it depends on the situation. But over here, I think taking 123 as the size will suffice. And see why we are concerned about the ASCII values over here, because when we say that we will be updating the corresponding index of each of the alphabet in the string in its index array, right? So we mean that we will be considering the ASCII value of each of the alphabet, and that ASCII value we will be treating as the index in the index array to update, right? So that's why we need the ASCII values. Now what I will do is I will also declare another index arrays for pattern, and it will be of the same size and will have all zeros. Then I will have another variable called count, right? I will initialize it to 0 and it will keep track of the number of occurrences of the anagram that we have seen so far, right? Then what I will do is I will iterate over uh, the pattern string. So I will say, okay, but before that I will have to declare the variables to hold the length of each of the strings that we have. So n1 can hold the length of text. Similarly, n2 can hold the length of pattern, right? this way. Now, since I have to iterate over pattern, I will say for I in range n2, and now what I have to do is, as I'm iterating over, the pattern string, I will have to update the corresponding index of the current character, or for each of the character, I will have to update the corresponding index in the index pat array, right? That's what I need to do. So what I will do is here, I will update the corresponding index of the current character of pat, right? And I will need to take the ASCII value of it, right? And ORD is the Python function that you can use to get the ASCII value of any given character, and I will increment it by 1, right? Now, see, what we need to do is, if you remember, we have to also update the index text index array with the corresponding indexes of all the uh, alphabets in each of the window, in each of the current window of when we are actually iterating, sliding over the text string, right? But now if you see the first window, which will get formulated in the text string, would be of the first n2 characters only, right? Because n2 is the size of my fixed size sliding window, and the first window will have the first n2 characters, right? So that's why what I can do is I can maybe make use of this particular for loop only because I'm iterating over n2 integers. So I can basically update my first window of the text string also, right, in the index text string. So I can update the index text string, and now I have to update the corresponding index of the alphabet in the text string, right, the current index, current character of the text string. And again, I will take the ASCII value of it, and I will update it by 1, right? That's it. Now for once, maybe I can do one thing after doing this first initialization of both the index arrays. I can just check if my index pat is equal to index text, right? And if they are equal, I will increment my count variable, which will say that I have encountered one anagram, right? Now what I will do is I will initialize a start pointer and an end pointer. Because see, this initialization of the index text array, we have done for once, right? For the first window, we are done, right? We have initialized it. But then now we have to slide it, right? And we have to consider all the fixed size windows of size equal to n2, right? So I will have to slide it. And for that reason, now I will have to declare two variables, starting and the end pointer. I will initialize start to 0 and end will be n2 minus 1, right? And then what I will do is I will run a while loop, and I will say that while my end is 1 less than the last character, right? Why 1 less than the last character and not the last character itself? Because I will tell you that, right? Why? So now what we can do is, now we have to remove one character from the beginning, that is my start pointer. I have to remove one element from my current start pointer and then increment my start pointer. That's what I have to do as a first step. So what I will do is I will again go to my index text, and I will uh, use the odd function, and then I will I will decrement the corresponding index of current starting character at the current starting point by 1, right? And then I will just move my start pointer to the next element, right? Increment it by 1, right? Now what I have to do is, as a second step, I have to add one element at the end, right? The next element at the end. So for that, I will have to increment my current end, right, by 1, right? And then I can just again increment my, like, the corresponding index of that new character in the index array by 1, right? And that's what I need to do. Right? So I have removed the first element and I have added one more element at the end, right? That's what I'm doing over here. And now you can see why I used the condition as less than n1 minus 1 and not n1, right? Because I'm just going till n1 minus 2 over here. And once I'm inside, I'm anyways going to increase my end by 1. And then I'm going to update, right? I'm like actually doing a post update, not a pre-update, right? And since I'm doing a post update, that is after in that particular iteration itself, I'm updating my end variable. That's why I need to go one element before the actual last element, right? So that my this particular statement doesn't go out of range, right? Index out of range. So that's the reason I used n1 minus 1. Now there can be like multiple ways of implementing the same algo, and you can do it your way also. But I'm doing like whatever I can think quickly, right? So that's about it. And then I will check after doing this update again if my index pat is equal to index text or not, right? If they are equal, I will again increment my count variable. And finally, once I'm done scanning the entire text string, I will just return my count, which will be my final answer, right? So this is the entire solution for this particular problem. Now maybe we can test it using the same test case that we saw earlier. I can say search. My pattern will be FOR, right? And my string was, the text was, let me copy actually, that would be faster. Yeah. And now if I run this, my output should be 3 because there are 3 occurrences of the anagrams of FOR in this particular string. So if I run this, so I get 3, right, which is the correct output. So this is the solution entirely. And as we have discussed, the space complexity is order of 1 because we are just using constant size arrays, and the time complexity is order of n because we are scanning both the arrays just once, right? So I hope you understood it, and I will see you in the next video. Thank you.